Again, welcome to DSRT 734 class. These lectures cover probability distribution. Our main objective is to determine the difference between discrete random variables and continuous random variables. Also, we are going to construct a discrete probability distribution and its graph. We're also going to determine if a distribution is a probability distribution and how to find the mean, variance, standard deviation of a discrete probability distribution. Also, how to find the expected value of a discrete probability distribution. So a random variable represents a numerical value associated with each outcome of a probability distribution. And in these lectures or our textbook, we are going to donate it by x, lowercase x. So for example, the number of sales calls a salesperson makes in a 1 day, again, is a discrete random variable because it's based on counting. So S equal to the number of sales calls a salesperson makes in 1 day. Also, an example is hours spent on sales calls in 1 day. This will be a continuous random variable because it's based on measurement, hours, the number of hours. Number of sales calls, again, we are counting them, so it's based on counting. And that's, again, discrete random variable. So a discrete random variable has a finite or countable number of possible outcomes that can be listed. So example, again, is the number of sales calls a person makes in 1 day. It can be 0, or it can be 5, or it can be 3, 2, etc. So a discrete random variable is based on counting. Then a continuous random variable is uncountable number of possible outcomes represented by an interval on the number line. So this is based on measurement on countable number of possible outcomes. So for example, hours spent on sales calls in 1 day, again, it's a continuous random variable based on measurement. Now we have an example here. Here they say we should decide whether the random variable x is discrete or continuous. So the number of stocks in the Dow Jones Industrial Average that have share prices increases on a given day. Again, the key word is the number of stocks. So it's based on counting. So this will be a discrete random variable. So the solution is discrete random variable because the number of stocks whose share price increases can be counted. Next example, the volume of water in a 32-ounce container. This will be a continuous random variable. We cannot count the volume of a water in a container. So it's a continuous random variable. The amount of water can be any volume between 0 ounces to 32 ounces. Again, it's based on measurement. In order to know if it's 32 ounces, we have to put the water on a scale to measure it. So again, the main difference between discrete random variable and also continuous random variable is that a discrete random variable is based on counting, continuous random variable is based on measurement. So next, what is a discrete probability distribution? Here we say the list each possible value the random variable can assume together with its probability is the discrete random variable. So the list of each possible value the random variable can assume together with its probability. Again, it must satisfy the following conditions. The probability of each value of the discrete random variable is between 0 and 1 inclusive. which means it's including 0 and 1. So the probability of X can be 0 or greater than 0, or can be 1 or less than 1. So between 0 and 1 inclusive. Secondly, the sum of all the probabilities is 1. So when we have a discrete probability distributions, let's say we have 10 outcomes, all the probability, the sum of all the probability of the 10 outcome should be 1. Again, we're going to see an example soon. So here we say let X be a discrete random variable with possible outcome x1, x2, up to xn. First, we make a frequency distribution for the possible outcomes. Then second, we are going to find the sum of the frequencies. Then we find the probability of each possible outcome by dividing its frequency by the sum of the frequencies. So this is like finding the proportion. And next, we check that each probability is between 0 and 1, and also the sum should be 1. The sum of all the probabilities outcomes should be 1. So let's see an example, and we are going to follow the 4 steps. Again, the 4 steps we have here. First, again, we are going to construct a discrete probability distribution. We need to know the frequency distribution for the possible outcomes. Then we find the sum of all the frequencies. Now, if we know the sum of the frequencies, each category of the random variable, we divide that frequency by the total frequency, and that will give us the probabilities. And from there, we can find the probability of each outcome by dividing the frequency of each outcome by the sum of the frequency. Then we make sure that our answer always should be between 0 and 1, and the total of the probability should be 1. So let's start the example here. So here we can see a table is given to us. We have the scores. The scores are between 1 to 5, and each score has its own frequency. For example, score 1 is 24, 2 is 33. So now the question said we should construct a probability distribution for the random variable X. Then we should graph the distribution using an histogram. Again, we covered the histogram in chapter 2. So when we follow the 4 steps, we say the first thing we need to do is that we know the frequency of each outcome. So next step, let's find the total frequency. Then we divide each score. Let's say score 1, the probability there will be 24 divided by the total. Score 2, 33 divided by the total frequency. Up to 5, 21 divided by the total frequency. So that will give us the probability. Now we have to make sure that all the probability for the scores from 1 to 5, the values are between 0 to 1. And the sum of all the probabilities should be 1. So let's start. So the first thing, as we said, we divide the frequency of each score by the total number of individuals in the study to find the probability for each value of the random variable. So this means if we had 24, 33, 42, 30, and 21, we should get 150. So now we divide 24 by 150. That's the probability of one score is 20. The frequency is 24. So we divide 24 by 150, and that gives us 0.16. Then probability of 2 score, the frequency is 33. So we divide 33 by 150, and that gives us 0.22. The probability of 3 score, the frequency is 42 divided by 150, that gives us 0.28. The probability of 4 score is 30 over 150. And we can check. Probability of 4 score is 30. Probability of 5 score is 21. If we had again all these values, we get 150. So that will be our probability values. Now we check. There's no any answer negative or greater than 1. We can see that all the probability values should be between 0 and 1. Then the next thing we need to do now is to come up with our discrete probability distribution. And this is what we are looking for. They say we should construct the discrete probability distribution. As we represent the score, so we have 1 up to 5, which is given to us. So this is the probability we find for each score. Now, if we had all this probability again, the answer will be 1. So how do we get this again? Find the total frequency. Then divide 24 by the total frequency, 33 by the total frequency, 42 by the total frequency, 30 by the total frequency, 21 by the total frequency. And that will give us our probability values here. Now, if we had all the probability values, we should get 1. And that's what we did here. The total probability at X, or the sum of all the probability at X, will be 0.16 plus 0.22 plus 0.28 plus 0.20 plus 0.14, and the total is 1. And also we can see that all the probability values are between 0 and 1. And there's no value less than 0, and there's no any value greater than 1. Next, they say we should construct the histogram. So from here, we can see the histogram. Again, we have our X values from 1 to 5. So we should get 5 bars. And the probability values will be our vertical axis. So for example, probability of 1 was 0.15, I think 0.16 or so, 0.16. So we're a little bit over 0.15. Then probability of 2 was 0.22, so a little bit over 0.2. And probability of 3, let's see, was 0.28. So almost a little bit close to 0.3. We construct all the 5 bars. Again, each bar represents the score from 1 to 5. And its probability will give us the vertical, the height of the bars. So next, we are going to learn how to find the mean of discrete probability distribution. Again, this is different from descriptive statistics, where we find the mean of the values by adding all the values and divided by the normal values. Here we are looking for the discrete probability distribution mean. So the formula to use here will be the sum of X times the probability at X. What this means is that, let's go back to our previous example. If I want to find the mean of this discrete probability distribution, I will multiply 1 by 0.16, 2 by 0.22, 3 by 0.28, 4 by 0.20, 5 by 0.14, which means I multiply each S value by its probability. Then we add or sum all of them, and that will give me the mean. So that's what this formula means, the sum of each X value times its probability. So we say each value of X is multiplied by its corresponding probability, and the products are added together. So let's see the same example here. We can see this is our previous example. We were able to, again, create our probability distribution table here. So now if we want to find the mean of this data set given to us, we are going to again multiply 1 by 0.16, 2 by 0.22, 3 by 0.28, 4 by 0.20, 5 by 0.14, and then sum all, and that will give us the mean. So first we multiply each score with its probabilities, then we add all. So that means the mean equal to the sum of X times probability P at X, and it will be 2.94. After we multiply each, we sum everything, 2.94. Next, also we can find the variance and also the standard deviation of discrete probability distribution. And the formula for finding the variance will be multiply the difference of each value and the mean, all square, with the probability of X, of that X value. So here we say S minus mean all square times probability of X. So let's say the X value, the mean was, let's say 2.94. The X value is 2, and the probability is 0.16. This means I'm going to have 2 minus 2.94 all square times 0.16. The probability at X is the probability of X value. Now, to find the standard deviation, we just find the square root of the variance. So that's the formula here again, square root of the variance. So let's use the same example. Previously, we find the mean was 2.94. Now, if they say we should find the variance, then I'm going to find the difference of X and the mean. So it will be, we first find X minus mean, 1 minus 0.94, 2 minus 0.94, 3 minus 0.94, 4 minus 0.94, 5 minus 0.94. So the difference of each value and the mean, in this case, is the scores. And we can see our solutions here. Then we need to square it. So we square the difference of S minus mean square. And this is the answer when we square each value. Now we multiply it by the probability of X. So which means I'm going to multiply 3.764 by 0.16, 0.884 times 0.22, all the way down. So that's what we have here. And that's the formula S minus the mean all square times P at X. So it will be 3.764 times 0.16. That is probability. The next probability is 0.22, 0.28, 0.20, 0.14. And that's what we did here, multiply by the difference of each X and the mean. Then after we finish, again, we sum everything. So we get 1.616. Again, we can look at the actual formula from our definition. We have sum here. So first of all, find the difference of each. First, we need to find the mean. Then we find the difference of each value, and the mean, we square it. We multiply by the probability of the X value for each category of X. After that, we sum all together. So do not sum the difference between X and the mean square. Then when you get the answer, then you multiply by P at X sum. And the P at X sum will give us 1, so it will not work. The first thing, as we see in the example here, first we subtract the mean from each S value, then we sum each difference of X and mean values, then we multiply by P at X. That's the probability of each S value. Then we sum everything here. So this will give us the variance. To find the standard deviation, we just find the square root of the variance, and that will give us 1.3. Next is, how do we find the expected value of, again, discrete random variable? Here also we have a special formula, which is almost same as the mean. Here we say it's equal to the mean of the random variable. So expected value is the same as the mean of the random variable. We multiply each X value by its probability, and we sum all together. So the expected value of X is equal to the mean. And same steps we did. So example is given here. Here they say at a raffle, we have 1,500 tickets that were sold at $2 each for 4 prizes. The first prize is $500, and we are going to get only one winner. $250 also one winner. $150 is one winner. Then $75, one winner also. Now you buy one ticket. What is the expected value of your gain? So the expected value of your gain here, we need to consider all the tickets that were sold also. But for example, the first gain, the highest price is 500. So if I subtract 500 from 2, that's my possible highest gain, 498. The second price is 250. If I subtract 2 from 250, then I can get $248 gain. The third price was 150. If I subtract 2 from 150, then I'll get 148, which is still good. Next is 75 minus 2, which is the last price. I will get $73. So that means the 1,500 tickets, only 4 of them I can get this gain. Possible. So the rest now will be 0. So I will not win anything. So I'm going to lose $2. Now the question said we should find the expected value of the gain. So this means we are going to come up with the probabilities. As we said, the total tickets sold was 1,500. Only one can get the highest price, and the gain was 498. So the probability there will be 1 over 1,500. Second, the same thing, one price, so 1 over 1,500. Third and fourth, they are all 1 prices, so 1,500. But now we have 1,496 tickets left out of the 1,500. Only 4 winners will come out. So this means the probability of losing is very, very high, which is 1,496 divided by 1,500. But our goal is to find expected gain. So as we all know, the formula is same as the mean. So we are going to again multiply 498 by 1 over 1,500, 248 by 1 over 1,500. It's like 148 divided by 1,500 all the way down. And also minus 2, which is my lose, times 1,496 over 1,500. So if we multiply each X value and its probability, and we had all together, we will get negative $1.35. So this will be my expected gain. So you can expect to lose an average of $1.35 for each ticket you buy. So again, the answer is negative, so it's a loss. If it's positive, then it will be gain. So that will be the conclusion of these lectures. So again, these lectures we focus on the random variable concept, which is the discrete random variable, continuous random variable, the difference between them, and also how to come up with the discrete probability distribution, how to construct it. And also we're able to find the mean, standard deviation, and also expected value variance of a discrete probability distribution. Again, thank you and see you in the next lectures.